Hey everybody, this will be Vectors Part 2, Day number 2, on equations of planes. We're going to form equations for planes today using one known point, and two vectors, as well as if we know 3 points. So let's go ahead and get started. Alright, so you can see this parallelogram, this blue parallelogram right here, represents a plane. What we can do is we can take a vector from the origin, this point 0, 0, 0, and shoot that vector up to a known point A. Alright, so that's vector OA. And then I can create this vector AP here by taking vector AB and adding to it the equivalent of vector AC. Right, so this vector right here, AC, gets translated over. Okay, so basically what we're doing is we're taking a point, creating a vector, and we're taking a certain number of steps of a second vector, let's call it AB, plus a certain number of steps of a second vector, we're going to call it AC. And that right there is fancy longhand for what we would call the equation of a plane in vector form. Okay, so let's talk about the equivalence here. OA, we call A, right? That's this vector here. Lambda B is lambda, or lambda AB is lambda B, and mu AC is mu C. So we take all the points of A, right? Here's parametric form. All the points of vector A are, so vector A would be A1, A2, A3. All the points of vector B, right, so vector B would be, now this is where it gets a little crazy, but would be B1 minus A1, B2 minus A2, B3 minus A3. Right? And then vector C, I'm not going to write it all out, but it would be C1 minus A1, and da-da-da-da-da-da. Okay, so basically, let me take you back to this picture right here. Let's say I wanted to find this point here. Right, let's call that point Q. Well, I could start at this point A, and then find a lambda and a mu that would get me there. And I can do that on any point on the plane. I can find a lambda and mu that would get me there, starting at A and finding my way to Q, wherever it might be. This parametric form here is helpful, but it is not the most helpful form that we'll have this unit. This is going to be our friend. This is the Cartesian equation. Okay, this is Cartesian form for the equation of a plane. Okay, for an equation of a plane. I think I spelled that right. Okay, here we go. Let's get on to an example. Okay, so let's say A is the point 1, 1, 1, B is the point 2, 3, 4, and C is the point negative 1, 0, 5. So point A, right, we could basically write this out like this. R is going to be X, Y, Z will be wherever we start, 1, 1, 1, plus lambda times B. B is not going to be the points for B. B is going to be, so what B will equal, vector B, if we look over here, would be vector AB, which is equal to all the points of B minus all the points of A. Okay. So vector AB would equal, looks like 2 minus 1, 3 minus 1, 4 minus 1. So it looks like 1, 2, 3. That's fair enough. Vector BC, let me write those in here. 1, 2, 3. Vector BC will be all of C minus all of A. Okay, let's do that. Negative 1 minus, excuse me, let's go back. Negative 1 minus 1, so AC will equal negative 2, negative 1, 4. Okay, so there's AC. Let's plug it in over here. Negative 2, no, I already forgot. Negative 1 and 4. Let's put this in parametric form now. So in parametric form, x equals 1 plus lambda minus 2 mu, right here. 1 plus lambda minus 2 mu. Y equals 1 plus 2 lambda minus mu. And z equals 1 plus 3 lambda plus 4 mu. Okay, so step 2 is done almost. We've completed at least putting it into parametric form, so we can check that off. Now we got to solve for mu and lambda. Okay, it's going to get a little interesting here. So what I'm going to do here, I'm going to keep this in the window, is I am going to, in these two, I'm going to pick something that'd be easy to solve or easy to eliminate. I'm going to eliminate mu in this, and I'm going to eliminate that same variable here. Okay, maybe I should do that in a different color. How about we'll do that in black here. Eliminate mu here. Okay, so in green, I could eliminate mu right here by multiplying the second one, the second equation. So let's write it out again. So x equals 1 plus lambda minus 2 mu, and y equals 1 plus 2 lambda minus mu. I could eliminate mu by multiplying this second equation by a negative 2. If I multiply it by negative 2, nothing changes in the first, so I'm just going to bring that down. But in the second, I would get negative 2y is equal to negative 2. Remember, it distributes everything, minus 4 lambda plus 2 mu. So when I take these two and I add them together, the mu's cancel, and I'm left with x minus 2y is equal to negative 1 minus 3 lambda. And I want to kind of hold that here. That's not, obviously not done, but we've got lambda all alone. Okay, so hang tight on that. Now I'm going to do the same thing in here. So I've got y in the second example, or second portion. I've got y equals 1 plus 2 lambda minus mu, and z equals 1 plus 3 lambda plus 4 mu. Okay, now I could see right away that if I multiply this one by 4, I'll eliminate them. So my new equation for that would be 4y equals 4 plus 8 lambda minus 4 mu. And I'm not going to rewrite the second one. I'm just going to ignore the first. I add these together. Looks like I get 4y plus z equals 5 plus 11 lambda, and our mu's are gone. Now I have two equations, and in this case, you might anticipate this already, but what I want to do in both of these is I want to eliminate lambda. Let's eliminate lambda. It looks like we're going to have to do a significant amount of work here multiplying both by something. So I got x minus 2y equals negative 1 minus 3 lambda. You might not understand what I just said. with regards to eliminating both, but you'll see in a minute. 5 plus 11 lambda. Right, negative 3 is not a factor of 11, and 11 is a prime number, so it's 3, so we're going to have to do a little bit work on both. So I'm going to multiply each of them by each other, kind of. So I'm going to multiply this one by 11, and they're already opposite signs, so I don't need to fiddle with that at all, so I'm just going to multiply by positives. Multiply this one by 3. So the first one becomes 11x minus 22y. Be careful, I screw this up all the time. And then minus 33 lambda. Okay, likewise for the second one, I get 12y plus 3z equals 15 plus, nice, 33 lambda. Now we know that we can do some elimination here. Those cancel, and we combine like terms. So I get 11x minus 10y plus 3z. Put a cross through your z's like I do, line through it so you don't think it's a 2, equals 4. And folks, that is the Cartesian form for that plane. I feel real good about that, so I'm just going to highlight it too. Okay, now we'll talk through the specifics of what it means. Okay, what does this actually mean? Well, this is the equation of the plane, so, you know, I mean, people have questions on what does the 4 mean? What does the 3, the negative 10, the 11, etc. mean? Well, we'll get to that a little bit later. But that would be using, in this case, 3 points to write the equation of a plane. Okay, some of you this is going to bother, but I'm not going to complete the highlighting that. Okay, let's try another example where we have a little different information given. Okay, here's an example where I'm given 2 vectors on a point. Now this is actually an easier example. Okay, find the vector equation, I'm just reading from the top, of the plane containing the vector b and c and passing through the point A. In each case, draw a rough diagram depicting the situation. Okay, so I'm just going to sketch something here. I don't like highlighter. Let's go back to our pen. Okay, here's the point A. Okay, here is vector C, and here is vector B. And basically what's happening is we're creating this plane, which of course has no finite edges. Right? The plane technically is infinite in surface area, but we can't really do a whole lot with the visual there other than just kind of make that surface come alive. So the vector equation is what we first want to write out, and that vector equation is going to look like this. X, Y, oh my gosh, it's way too small. Let's try again. Keep the point there. There we go. X, Y, Z. Right, where do we start? We start at A. 4, 1, 5. And in the other example, we had to take, some points and do some subtracting. This is much easier. All I'm going to do is take the vectors given, because they are already direction vectors. We know that they go through that point 4, 1, 5. Therefore, I'm going to take vector B, which is 2, 2, negative 1, multiply it by lambda, and then add mu times vector C, which is 2, negative 1, and 3. So there's vector form of that equation. Now, coming up with Cartesian form, we're going to have to do a little work by putting this into parametric form and then going from there. Okay, so I get x equals 4 plus 2 lambda plus 2 mu. I get y equals 1 plus 2 lambda minus mu. I would suggest in this case, I guess you could go either way with it, either multiply one by a negative or the other. Okay, I'm going to rewrite y over here as well. I'm anticipating the work that I'm going to have to show here in a moment. And then z, which is 5 minus lambda plus 3 mu. Okay, so it looks like to me what's going to be easiest. There really isn't an easier variable to eliminate. So I think I'm just going to eliminate mu. Okay, I'm going to eliminate mu. And in order to do that, I'd have to multiply this the second equation here by a 2. So you can see that the x wouldn't change. 4 plus 2 lambda plus 2 mu. And this would become 2y. 2y equals 2 plus 4 lambda minus 2 mu. And you'll see those mu's, they'll go away, they'll cancel. So what I get is x plus 2y. This is basically what I did on the previous example, except one step less. I didn't have to find those direction vectors. Looks like 6 plus 6 lambda. I'm going to hold on to that for a moment. And here, what I'm going to do, it looks like I'm going to multiply this first one by a 3. I'm going to bring that down here. So I'll get 3y equals 3 plus 6 lambda minus 3 mu. I don't have to change the second equation at all. So I'm going to add those two together. I get 3y plus z equals 8 plus 5 lambda. And of course, the mu's are now gone. Now I'm going to eliminate lambdas. There's just typically no easy way to do it other than multiplying both by some factor. And in this case, I'm going to multiply this one by a -5. And I'm going to multiply this one by a +6. I want them to be opposite signs. So if I multiply by -5, I get -5x minus 10y equal to -30 minus 30 lambda. I do the same thing over here. It looks like I get 18y plus 6z and 48 plus 30 lambda. Okay, close, almost done. Cancel. Let's see what we get. Looks like -5x plus 8y plus 6z equals 18. All right. Yeah, that's it. That's the equation that we got here. It looks like I may have done the second part without knowing it. Let's see here. Part C was find the vector equation of the plane. Okay, so part C I completed. I was done here. And then I did number 2 with the rest of this work. So the rest of this work was finding the Cartesian equation of the plane. Okay, you guys, that's it. That's finding equations of planes using 3 points or using 2 vectors and a point.